Hello and welcome to the Robotics Lab of Heriot-Watt University in Dubai, and welcome to be an automation engineer for a day. So we're here with some of our autonomous robots and our automation devices, and here I have on my left Popeye. Popeye gets his name for being a strong arm, and it will be the focus of today's task. Essentially, Popeye is very good at doing repetitive tasks at very high precision, something that is used a lot in industry, in manufacture, in many different processes that engineers are involved in. But before we get into today's task, we're going to look at perhaps a little bit more futuristic, some of the future of automation, autonomous, robotics, interactive systems. And what I have here, I invite you to take a look at one of our robotic dogs. So this is a very clever device. Essentially, he's a bit of a character as well. As you can see, he's very nimble on his feet. He's able to move around quite well, and Mohammed here is controlling him. So in a way, the engineer or the user is able to control something like this to go into harsh environments, to go into areas where humans may not want to go for inspection purposes. And to do that, traditional devices have not been very good at getting around, whereas something like this is able to react a lot to particularly difficult terrain. Now, on with this one, it's quite smart as well. Maybe you can give us a bit of a demonstration about how it can move around just over and back. Quite nimble, like that, and quite quick. Excellent. But on top of that, he has got lots and lots of sensors. So I'm able to, or it's able to be aware of its environment, aware of its surroundings. And an example, in a harsh environment, one that might be changing, one where they're moving pieces like other devices or other people, be able to react to them. So if I put my hand in front, it knows to move backwards. You can bring them back to me, and maybe on the side, if I was to push on the side or stand to the side like this, it's going to move to the side to react to a changing environment. And that means that this type of robotics has a huge amount of potential to do things that in an autonomous way, in an automated way, tasks that traditionally have been to preserve or needed more human interaction.
True. This is obviously now I'm controlling it, so it's more of remote control, but it's fully capable to be autonomous operation. So on top of the robot here, we got a LiDAR, which basically make a 3D visual image of its surrounding and then can navigate it through. What the obstacle avoidance that you covered is basically added value. So if that environment change or there is dynamic things moving around it, then can manage to get it through and reach its target. The fact it's using what we call it a crawling mechanism here, it can go into harsh environment, climb stairs, for example, or even jump around and move in very nimble ways.
Excellent. So another example of what we use in automation, in robotics, in autonomous interactive systems, these really high-tech new devices, is one that we're going to demonstrate here with Richie, and also been modeled by Musin, who is wearing the VR headset. You can see him waving there. And what's important there is what Musin does, Richie does. So it's that kind of interactivity and automation. So in theory, Musin doesn't need to be beside Richie. Musin could be in the room next door, could be in a different time zone in a different country, controlling, interacting, and aware of its environment and making decisions or being controlled by Musin. So one example, I'm going to ask Richie to shake my hand. If I put my hand forward and give this a grasp there and shake my hand up and down, able to do just that. You can see even as Musin lifts his head and puts it down, so too does his head move up and down. And you can see through the screen what Richie can see. So let's give a bit more of a demonstration. Can you put your hands up? Can you do waves them about? We'll stop there before we do the Macarena. Great, so we're going to get on now with today's task. It is about how we use devices like this, these type of robotic arms to do autonomous things, to automate things to do a particular task. So with that, I'm going to hand over to the instruction and to today's task. I hope you engage with it, and I look forward to seeing the different designs that you create in this task.
Moving to the task, we are going to use the web tool available at robodk.com/web. This is identical interface to the software package called RoboDK that you can download if you want. The downloaded package will have additional features, but also it comes with 30-day trial period only. On the web, you can use all the features, but your programming and simulation will be a bit limited. However, it's more than enough to what we are going to do today. I'll start by briefing you about the buttons you see in here, which are not many. Here you can open or load files. If you have a 3D model or if you have a robot file, that you can load it from here. Here is the online library that have got lots of robotic arms and automation solutions like conveyor belts, tables, grippers, and so on. Here where you can save your station, and what we are going to build is a station. And here we got reference frames, target, which we are going to use later. This is here very useful related to the view, and always you can click on isometric view to get to the home view, and here to exchange between what you are doing with your mouse pointer. Is it moving the reference frame or not, or just using a pointer, or working with the TCP, which is the tool center point. The simulation speed here, or if you want to stop it, and these related to programming. So here to start or add a new program, and then two types of programming really in robotics, either a joint movement or a linear movement, and we'll get to see these options. So let's get started with our station. I would look like first to get to the open library, online library, and as I mentioned, there is lots of robots and they are organized with a brand type and so on. I'm going to use the search function in here. I'm going to search for a table, and I'm going to start with getting this table here. It will take a second to load. You will need to give it some time because this is working on your internet browser and using some graphics. So you will need to have it to load. In case you're working with RoboDK web and it doesn't load these objects and you don't see any progress, you can download these files and then use the load file from here. So here is the table. Now I want to get my robotic arm. I'll probably go with the brands this time, and there is almost every robot brand you work with. We may later use Quinoa because we have it in the lab, but now let me just go with a Kuka robot and search without the table. And here I got variety of robots in here listed with their specifications. Let's go with the KR3. I will open it, and here is it. Now it's a bit outside the table, so I'll need to move it in. But let me get it a tool, and the task, what I want to do here, a very basic task. I'm going to import a 3D file, and I'm going to try to spray paint it. As I mentioned, you can do so many things. So let me just go with paint. Again, searching here. And I got a generic paint. Let me select the robot and then open the paint sprayer tool. And as you can see, it was installed directly to the end effector. And also that red marking shows the spray paint. Now I need to move this inside. I can either click here on move reference frame, and you can see all the different reference frames, which I'll tell you what all these arrows are. or I can remove them. If these arrows are too big, you can reduce or increase, if you want, your size, their size, by using the minus and the plus signs in your keyboard. So I'm just now using these buttons to do like that. I'm going to select move the reference frame. You can also do that by clicking Alt in your keyboard. If I click Alt on my keyboard and hold it, I can get to the screen or get back without Alt, or I can just hold it. Let me do that. I will now use my mouse pointer to click on the green axis in there, the Y axis. I want to get that robot right in there. Let me get it to the side, and this looks much better. And this is what does it, moving the frame or the reference frame means. Now if I go back to the normal view, my left click is basically can select different objects. If I double click on anything on the screen, wait a second and you will get its sub information. This time is the robot, the KR3, and if it moves to any place and I want to get it to home position, I just click home. I get the coordinates, the angles, and everything related to that. Click on the table, double click, again we'll get information about this table, the sprayer, same thing, gripper, and so on. And I'll show you example later on the gripper. Okay, so we have got this. Let me get an object that I want to 3D print, and I have already produced a 3D object. Let me close this window and navigate to 3D objects, and here we got it. I am going to spray paint the engineer for a day letters in this case. So I wait for a second and it should come somewhere on this world. Perfect, and you can see it in here, but that's too nearby the base. I want to move it around. So I'm going to double click on it, and I need to make sure that it's not the table. This is here on the right side. So let me just zoom in. I'm using the scroll in my mouse to do that. Click again, and here I got EFAD, and this is the file name. 200 is the size that I refer to. And use the scroll, and let me just move it into the X direction. As you can see, these colors refer to what you see in the screen. Red arrows are referring to X, green is Y, purple or blue is Z, and then R is referring to rotation or angle, rotation on X, Y, and Z. So I want to move this, let's say, to 650 centimeters or millimeters. Okay, this looks good. I just want to rotate it by 90 degrees. Okay, as you can see, I have got my letters. Engineer for a day. And I hope that you're enjoying it. A bit with the mouse, you can also right click to get some options based on where you right click. If you hold the scroll or the middle key, you can move your station left and right. If you hold the right click, you can change the view, as you can see. For example, I want to see a top view. And if you want to get to the isometric view, just go up there and click once, and that will get me to the home position. Okay, now we have the robot, we have the tool, the sprayer, and I do have my letters. Now it's time to make the operation, the program to move it. I don't need to tell you, but in reality, working with robots is all about accuracy. So we do measure twice or thrice, and we enter all these coordinates and dimensions into the program, into what the robot does. However, in this demo and getting started with automation, we are going to use these reference frame, move them manually, and generate a basic program just so you get hold of things. But this interface, RoboDK Web, is capable of doing all what you want to do with automation. So let's get started. I want to set now targets, and targets are the points where I want the robot to reach, or its tool center point, the tool that's installed to the robot in case the tool is installed. So I'm going now to select my robot, in this case here, and I'm selecting a target, this position. So I want to use this position as maybe a parking position, but then I will move it to do the spray paint. I will need now to click on move reference frame, or click and hold Alt on my keyboard. And now I will start moving these arrows all over the place. I want the tool to come a bit down, or the sprayer. So I'm going to click on the blue line, the Z-axis of the tool, and move it forward. Yeah? And you can see manually I can do that. And just to show you, if I move somewhere and I lose where is my home position after so many different movement, let me just do all these movement, and let's say I messed it up. I want to get to the home position, double click on the robot, wait for the window to appear and click home here, there, and that will get it to the home position. So this is always somewhere to get back to the home position. Okay, now let's get the sprayer to move a bit. Well, now these arrows are sometimes not very easy to see, so feel free to zoom in, zoom out to get into where you want. And as I mentioned, I want to start spray painting my engineer for a day letters in here. I probably should do the logo. Okay, so that is a second target, and this is where paint starts. So I click on target, and now as you can see on my station tree, I have two targets: the initial position that I stored, and now this point. Now if you think about it, I don't really care how the robot make its movement between target 1 or target 2, or from target 1 to target 2. This kind of movement we call it joint movement, just reach to the point. Now with painting, I want the movement to be only linear, so we will make sure later in the program there is a linear movement. Let me show you what does that mean. That means I want to do painting like that, set a target, and then, you know, with painting it's always to have multiple layers. Second layer, and here we got our, oh, that was my, okay, so what you have seen just now, a change of a frame, and you see a duplicate of the arm. If that happens, hit escape in your keyboard so you get back to your reference frame. Okay, and this is my second layer done here, and that's it, over. I want now to get the robot all the way out from this place, so I will have to do this, and you can do the movement in different, just like that, and this is my target. Perfect. Now this is all over, and I think I am good with the targets. However, as you can see, all these targets now appears with all these reference frames, the arrows, but there is no program. If I click on a target, a robot, depends on the interface you are in, it could go into these targets and move, but there is no program yet. So let's add a program. I'm going to click on target 1, hold shift on my keyboard and select the last target, basically selecting all of them. And I'm going to now click on a program, and that is an automated, easy way to do a program here. And you can see I have got a program. I got an error. I will tell you more about this error next, but I want to show you here. So this is the program now, and you can see there is a reference frame, there is a tool involved, and there is different movements. Move J is a joint movement. Move L is a linear movement. And in robotics, there is something what we call it singularity, and that happens when there is alignment between two joints, especially joint 5 in this case, as you can see. So we can fix this by moving our reference frame a little bit, or use a joint movement if appropriate, and if it doesn't it cause problems. And you can see it's suggested here, consider a joint movement in state. So if this happen, you will need to find out which of this linear movement is causing a problem and change it to joint movement, or move the reference frame to somewhere to avoid that a slight bit normally. So let's click OK on this, and you can see I got a yellow line there. That yellow line represents the movement of the tool center point, TCP again, from this target to the next target. And as I operate the simulation and solve my errors, you will see a full run of this yellow line. Let me just try to run the program and see where it stops. To run it, you can double click on the program here. To run only one line of the code, you can just double click on one of them. So as you can see, this is now making an issue here. So move L is causing a problem. Perfect. Well, could have multiple ones. So let's right click on this and let's change this movement to joint and see what happens. Okay, so you can see now it can move between these two targets or two lines of program without an error, because we have moved to a joint movement. You still can see that it's called move L, but we have right click and change that to joint movement. So let's click on the program, and this is absolutely what I have done. This is a bit fast, and here where you can change the speed. As you change, you should see on the lower side of the window, which might not appear very well in this case. Let me change, and here you can see it. So let me change this again so you can see it. Simulation speed set to 50. Well, that's a lot. Let's set it to somewhere at 1 or 2. Sometimes it's a bit tricky, but I here have set it to 1. And let me just run the program again. It starts where I set it to start here, go do a layer 2, and then go up and wait. And you can see now the yellow line is complete, and this is our first program and the first station running all well. I'll show you a couple of other things, and then we'll leave you to play around with this very cool tool with the hundreds of ready library items in there. Let's just have a look into how this works from different angles. And again, let me close this. Let me zoom in. Probably like that. Great. Double click on the program, and you can see. So as you can tell, I have not programmed any of the joints of the robot. I have just decided where the tool should be, and then all the magic happens on the background, which sets the coordinates, and this program can now export it to an actual KUKA robot KR3. Obviously, if you use another robot from another brand or with another model, you need a different code. Okay, let's get to see the engineer for a day. I will reduce the arrows here by hitting the negative sign on my keyboard so they don't distract my view, and run it one more time. The sprayer is coming, paint a layer 2, and go. Okay, that's very cool. Now let's go back to isometric view. Okay, that is cool. Now you can certainly save the station if you wish. I'll do that. And I will call this demo 1. Perfect. Now, if you want to start a station, a new one from scratch, you can simply delete everything here on the tree, or you can just refresh, which is also sometimes a tricky thing, because if you refresh your browser, all your work is lost unless you have saved it initially. So be careful when using this. Don't use the back button in your browser. Use only the controls that are available here within RoboDK Web. Now we are done with our very first automation station. We are very interested to see what creations you come up with. Give it a try and keep us posted.
So now you've done your designs, you've programmed your arm, your robotic arm, to do a task, spray painting, I believe, and I'm going to hand over to Mohammed to give us a demonstration of some of the programming, some of the designs that have been used to program, well, Popeye.
Perfect, thank you. I wanted to cover some aspect that was in the task and you have come up with through your, I would say, programming aspect. I wanted to discuss in particular the joint and line movement. In such setup and robotics automation, we always refer to the end effector as having the tool fixed in. So in this case, for example, we do have this dial gauge here, and that point could be the tool center point. So all the programming that you have done was referring to this point. In your case, obviously,